Hey, James.
How's it going?
Pretty good. How about yourself?
I am really tired.
I am too. Understandable.
That's what I get for staying up late all Memorial Day weekend.
Oh, well, hopefully it was for good reason.
Just hanging out with friends, so that
Yeah.
ain't good enough for me.
Yep, absolutely.
Anyways, how was your weekend?
Uh, Uneventful, pretty much. Just my son had a baseball tournament, so we had a
Nice.
couple games. We had a barbecue. Just typical.
It still
So
sounds like fun.
yeah, it was good. I'm too old to stay up too late though, so I'm usually in bed by 10.
Yeah, I wish I could say that. I was doing homework up to like 3 in the morning last night.
Oh, I do have nights like that though, believe me, but I pay for it the next day, that's for sure.
You know,
One of my classes, it was nice of the instructor to give us extra time for assignments that were normally due on Monday, but since it was a holiday, he extended the due dates out a little bit. But at the same
right.
time, it causes me to then procrastinate that. And so I still have
Yeah.
those assignments in addition to the regular weekly assignments. So it's like, doesn't really help me in the end.
Yeah, I totally understand that.
Hey, Dorothy,
Hello.
how are you?
Good. How are you guys?
Good, thanks.
Good. I have to say this homework is a little challenging for me. Between all like Excel, I don't know, just the different Excel spreadsheets we use and
Yeah, knowing which one to use is the hard part.
Yeah, and I'm like watching the video of him like going over the problems,
Uh-huh.
and he is confusing me
Yeah.
a lot. Like it kind of seems like he doesn't go in order sometimes.
Oh, yeah, the tutorial, the extra
Yeah.
video, yeah. And then he goes off to the side and he's like doing something on the computer, but we don't see what he's doing.
Yeah, and then after that, he has the video that continues and it does, he shows what he was doing on Excel.
Yeah.
And then he shows on SPSS, which,
I've never used that, so that looks way
yeah.
confusing to me.
Yeah. Well, at first I was like, is that what Excel looks like on a PC? I was so lost.
Yeah.
But that's okay. We'll be able to figure it out.
That's what we're all
Hey, everybody.
Hey, Josh.
Hey.
Have you guys already started?
No,
No.
not yet. So, and I think the guy that does the two videos, the part 1 and part 2 videos, his voice is like monotone or he's talking too fast or something. And I just feel like I don't even understand what he's saying.
Yeah, I totally agree.
So,
well, and he does go really fast.
yeah.
But then sometimes I'm like, okay, come on, like we can move a little bit faster. It's like back and forth.
Yeah. All right. So, do you guys want to go over anything on part 2 of lesson 12? Or should we jump right into the quiz?
I'm good to go right in, but
Yeah, I'm good with jumping in as well.
Yeah, I think I am.
All right, let's do it. All right, number 3. Let's see. Well, you are required to work together on this quiz, blah, blah, blah. There's the t-distribution applet you need to open. And some data. Let's open.
I also feel like I have a million Excel spreadsheet opens or spreadsheets open at the same time.
Yeah.
All right.
Yeah, 3 decimal places. All right, suppose we have a set of paired data and let D equal X after minus X before. The null hypothesis is equal to 0. The alternative hypothesis is not 0. The population standard deviation sigma is not known. Jordan collects a sample of size of 9 and computes, what does that stand for again? The mean of the difference is 2.2, and SD is 3.3. What is the value of the test statistic? So we need to get the t value, right?
Right.
Let's see. We just plug all these numbers into the one sample test.
I think so.
Wait, is that a spreadsheet you're plugging it into? What was that?
Yeah, I think so. In the Excel, the one sample t-test.
I think you can just compute it using the equation. I think it's 2.
Which equation? The
So it's t equals d bar minus 0 divided by the SD divided by the square root of n.
Yep. Okay, let's do that.
Trying to pull up that other. What was the name of the Excel document we used last time?
Quantitative inference
Procedures.
Mhm.
procedures. Yeah.
Ginger, is that what you were initially talking about?
Yes, that was the spreadsheet.
Okay, I was like, I've never never heard of that other one, but now it makes sense.
I have a question for you guys. Though. Was that homework quiz a lot harder?
Yes.
time? I could not figure out the first part. It was driving me nuts.
Yes, it was.
I was totally like stressing out. Like my husband was looking at me like, "Are you having a hard time over there?"
Yeah, I literally spent 4 hours trying to figure out that and the group quiz because I wasn't there for the meeting or whatever. By the way, sorry.
Sorry, I know I feel bad.
Oh no, that wasn't you. I was supposed to be done by 8:15, but I didn't get done in time. So
Yeah, it was tough. I'm nervous for this next exam that we have.
I know, me too.
So
I'm glad you all had a hard time with it though too, because I was like, am I just dumb and not getting this? But
I think it's actually easier than we're making it out to be. You know, I think it's if we just plug in the right numbers, we'll get the right answers, but it's just knowing, you know, where exactly those numbers need to go. Because sometimes it's like the confidence level is the 0.95, but then sometimes it gave you like the, what was that? The 0.05, you know, the P that you compare to the P value. And I don't know. It's just, it was confusing. But anyways, back to the quiz. I did get 2.
Okay, so that was right then?
Yep.
Well, as far as we know.
There.
Is everyone good on?
So the way that we get that answer, we just put that in the one sample t-test for means, like the quantitative inference procedures worksheet.
No, actually, we just worked out the equation. The T equals D bar minus 0.
Oh, okay, yeah.
SD divided by the square root of n.
Okay, yeah. It's been a while. It's been a while since I did that. Okay, sounds good.
Did you get that, James?
Yeah, I got 2.
Okay.
I'll read the next one. Are you good, Dorothy?
Yep.
Okay, cool. The probability of obtaining a test statistic greater than Jordan's test statistics is 0.0403. use this probability to determine the p-value for Jordan's hypothesis test.
You just
So
use
that
that.
one, I think we used the Excel thing, right?
I think you just use the applet, right?
I think so.
Mm-hmm.
And you just put that in the area.
Yeah.
Is it
And
the
then do
area
T.
or a t? Because that isn't the test statistic the t value.
Oh, yeah.
Was that that? Oh, yeah. Use this probability to determine the p-value for Jordan's hypothesis test.
But we
What?
don't know like the degrees of freedom and stuff like that. Does that matter?
Mm,
Hmm.
I'm not sure.
It would matter. It'd change the area a little bit, depending on the degrees of freedom.
Right.
Oh, no, it would be the probability. So if you read the question, the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. So that is a probability. So would you not just put that in the area of the applet? Because I think you leave the shading where it's at. And I think it'd be 3.472.
So we put the 0.0403 in the area.
Yeah.
What do you do with the degrees of freedom now?
Yeah, that still doesn't.
Or do we put it in the original?
So we keep it at 3.
Yes. What is the, I mean, how do we determine if this is normal or not? Like, does it say somewhere? Because it doesn't give us a test size,
Right.
and maybe we just assume it's normal. I don't know.
Use this probability to determine the p-value.
Wait, aren't we're supposed to use the information from above, aren't we? Yeah,
Oh,
it says for the next
true.
2 questions.
Yes, it's for the next two questions. So there we go. Okay. So then our degrees of freedom should be 8.
Oh, I see. Okay, that.
Oh, yeah, because n-1.
Mm-hmm.
So in the applet, we put 8 with the degrees of freedom.
Yeah. So then we put those degrees of freedom and then put the number in. 0.0403. Okay. And then we shade, was it the outsides or the center?
Let me look.
It would be the center.
Greater than,
Wait.
I think
It
we just
said-
find the t-score, right?
Oh, greater. Yeah, so it'd be to the right then, right?
mm-hmm. That's what I'm thinking.
I think for that question, we're just trying to find the t-score.
Yeah, probably, because if we only shade since we already have the probability,
That's true. We wouldn't need.
yeah, we don't do the shading because that changes the probability if we change the shading. So we must be looking for the t-value. Which,
I have 1.99.
yeah, do we put that or do we just put 2?
I think 2, because we have to round it up.
Mm-hmm.
How did you do
1.9.
that one? How'd you get 1.99?
Yeah.
So I put the degrees of freedom 8, and then I put in the area of 0.0403, and then that gave us a t-value of 9, or the t-value of 1.99.
Mine's 2.444.
I got 0.052. What the?
Hmm.
Okay, I did it again, and I have 2.444 for the t-value. But that's,
Yeah, me too.
I wonder if does the shading matter? Because
If
it's,
you change the shading, it takes away the area.
because the area changes when we do the shading. And if we're looking for the probability or test statistic, let's see, the greater than the test statistic means that we should shade the right. Wouldn't that be right?
Mm-hmm.
Then put in the area of the 0.0403. which gives us 1.99.
Oh,
Yeah, I keep on getting
Yeah, okay, I see.
1.99.
I am not getting that.
So
That
Josh,
is so weird.
Josh, I have a. You just have to shade everything only to the right, and then type in the area as 0.0403 again, and it's going to change
Yeah.
the t value. If that makes sense.
Oh, yep, I got that. Cool.
So we'll just say 2, round it up to 2.
Yeah. All right. And
Looks like we're moving on to the data A. For the next 6 questions.
So we should probably just copy that over then.
Yeah.
See you later.
yeah, have a good day. Sorry, guys.
Are you putting the data into the paired sample t-test?
Yeah, that's what I'm doing.
Okay. Because we got to find the difference, right?
Oh,
Right.
yeah, I was putting that in the wrong one. Okay. So let's see.
Did you guys get all of the differences, or did it change on you?
Well, I put in the calculation for it to compute the differences.
Where do we put the? Oh, so we need to put in like the mean and the standard deviation and everything.
No, so what I did on the paired sample test Excel sheet, I copied
Yeah.
the 2 columns and put them in variable 1 and variable 2. And then in column C, I just computed equals A6 minus B6, and then just copied that format down the column.
Oh, I get you. Okay.
Wait, where'd you do the A6 minus B6?
Into C6. So in the differences column,
Okay.
Oh, that makes sense. Yeah, because you delete.
corner down.
Yeah, because if you delete the numbers, it gets rid of. Okay, yeah, I'm following you.
Okay, well, I just am confused. So I put mine in C5. Is that wrong?
Oh, yeah, I guess I'm just 1 column off. Yeah,
Okay.
sorry.
Okay,
Yeah.
no, you're fine. I'm just making sure I didn't erase something that I needed to. Needed not to. All right.
Did you guys get 0.047 or 0.407 for the t-test?
Yeah, that's what I got.
Do we need to put that
Point-
level of
wait,
significance in anywhere? We don't, right? Or are we?
Yeah, because we were only supposed to fill out one or the other, right?
Yes. Yeah.
Okay.
Learned that the hard way after 2 hours. Trying to figure it out.
Yeah, we don't need to put in the summary statistics table. But does our confidence level go down to 0.90 since our level of significance is 0.10? Do those correlate? It seems like those have always correlated to me in a way, but maybe I'm just making an association that's not there.
I'm not sure.
You might.
Significance is usually 0.05, and we'd always look at the confidence level as 0.95. So
Yeah, I think you're right, Ginger.
Yeah, but it won't change the t-score though. The confidence level.
okay.
So it's still going to be. It'll change like the p-value and the confidence interval, but not the t-test.
So the next one's what's the p-value? So we are going to want that there.
Yeah.
You guys got 0.407, right, for the T?
Yeah.
Mm-hmm.
The p-value we got. This is where my numbers were sometimes off from what the videos were showing.
Yeah, because the p-value changes the most, I feel like.
You guys have 0.688 or 689, I guess.
Yeah. Yeah.
Yeah, I
Let's
have
go ahead and
0.689.
try that and then see.
Yeah,
Yeah.
that's what I got.
I know some of them, it was
0.689.
like, you need to divide that number in half.
Yeah,
Oh.
I remember that.
I wasn't sure when to do that, but maybe
Maybe-
that's only when it's a one-tailed, and this is a
Which-
two-tailed.
Yeah.
Yeah. Wait, I thought this one would be one-tailed because we only shaded one side.
That was the previous one. This is a new,
Oh, new problem.
yeah,
Okay.
yeah, because this one does not equal 0, so that means we're looking at both sides.
Okay.
Greater than, less than.
All right. So it looks like, so in 7, are we good to move on to 7?
Yeah.
Yeah.
What is the correct decision based on this evidence? So since our p-value is greater than our level of significance, then we would fail to reject.
That's what I would say.
Right.
So we got fail to reject.
Well, to reject, yeah.
Sorry. Cool. I'm gonna move real quick because my room has terrible Wi-Fi and my roommate just left. So I'm gonna go steal his room and go in there and do it. Fine.
So number 8, we just changed the type of test to greater than instead of equal, or not equal.
Yeah. Greater than.
And so then our p-value is 0.34.
Which is still greater.
Yep.
Wouldn't it be that you have insufficient evidence on number 8?
Right.
Yeah, because we still failed to reject.
Yep. That's what I would say. So B.
Yeah.
Mm-hmm. All right.
New data.
Turn.
Sure.
Cool. I'll read it. Chapter 12 data. To answer the next 8 questions, perform a paired sample t-test in SPSS. Be sure to do the test for group 1 minus group 2. The data comes from, no, I'm not going to read that. The null hypothesis is equal to 0. The alternative hypothesis is not equal to 0. Level of significance 0.01, which is greater N or DF.
That's
Gonna
going to be
figure that
another
out first.
two-tailed, not equal to.
I got N is greater.
So you got 22 for N and then 21 for the DF?
Yeah.
Okay, yeah, me too.
Yeah, that's what I got.
How'd you get 20, let's see.
Sorry?
I have,
Oh, mine's still on greater than though. What do we need it on?
doing that. Okay. Yeah, so never mind. N is greater.
Okay.
Do we need to do, so we need to change it to 9.99, right?
Right.
Our confidence level.
Won't change the sample size or DF.
Yeah, but for the next question, sorry,
N.
because do we want it not equal to or greater than?
Yeah.
So greater than?
Yeah, we want it to be greater than. Okay.
Yeah, not equal to is what it should be, right? That's what we're working with.
It is not equal to.
Yeah.
All right, so the p-value is 0.0012.
Yep. So just 0.001.
Okay. Okay, so our p-value is less than.
Yep, so we'll reject the null hypothesis.
Yes.
Mm-hmm.
All right, you decide to try another alternative hypothesis. This time you use that the mu of the differences is greater than 0 and you keep the same level of significance. Did the p-value increase or decrease?
Decrease.
Okay.
We would still reject, right?
That's what I would say.
Right. It'd be reject.
Mm-hmm. All
Would
right.
that be C for our answer on question 14?
Yeah. There's a mean difference between the two groups.
All right.
15. As we've seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value?
So we just gotta change the greater than thing.
Well, less than has the highest p-value.
Yeah, it seems that greater than probably.
Yeah, greater
Well.
than the lowest.
Yeah, that's what I
Let's
got.
go D then.
Was it 0.1 then,
So-
or 0.001 when you round it? Oh wait, just kidding. I'm thinking of a number value. Sorry.
Yeah, so it's just D.
Yeah, that's what I'd pick. Oh no, actually it'd be B, right? Wait. When, oh yeah, when it's greater than, yeah, I'm sorry.
You're fine.
Yeah, D, right?
Mm-hmm.
Yeah, so mu is greater than 0.
Right.
Okay.
I can read this one. It says determine the 95% confidence interval for the mean difference between the two groups using group 1 minus group 2. Input your answers below. So do we just need to change that to 0.95?
We're still
Yeah.
using the B thing, right? Then
Yeah,
Yeah, the second document.
document B.
what is the point estimate? Let's see, what was the point estimate?
I forgot what that was too.
So we have a confidence level of 0.95.
Sample mean is the point estimate, which is the D bar. Do we have a D bar? Or the X bar? They're both. I don't have any of these.
So would that be 11.955?
I'm not sure.
I don't
I
know.
don't remember.
Would we get 11.955?
That's the mean of the differences.
Mm-hmm.
Oh yeah, I think you're right. Yeah, that would make sense.
Let's try that out.
All right. The Wi-Fi totally cut out there. I didn't hear a word you just said. Sorry.
11.955 on the Excel sheet. That's the mean differences between the two variables. So we're guessing that that's our point estimate.
Gotcha.
The D bar is the sample mean difference. Let's give that a try.
All right.
And then would the next one be the standard error of the mean? Is that what that is?
I think so.
Margin of error. So we would take the SD divided by the square root of n. Do we need to calculate that?
I think it's 3.11, but let's try it anyways. So what's the SD on this one? Is that the
15.003.
The sample standard deviation of difference. Yeah, so I think that's the 15.033. Yep.
Okay.
Or
And then
zero.
we divide that by the square root of n.
Yep.
All
20.
right, and n is 22 right now.
I got 3.198.
Mm,
I got 3.198. So yeah, it's the standard error of the mean to the just to the right of
What's
that
the difference?
3.199.
Yeah.
Okay.
Which we know how to calculate it though, right?
Yep.
All right, so the lower bound is 5.303,
Yep.
Yep.
and then 18.607.
Yep. Oh, is that all of them?
Yep.
Cool.
And submit real quick
Right.
first. All right, we missed number 4 and 15 and 17.
4, 15, and
Those again?
So we missed number 4, number 9,
Okay.
15, and then 17.
Four.
All right, so let's all just start number 4 again, I guess.
Yeah.
Maybe the 4 is just supposed to be the 1.99. I wonder.
You can go ahead and try that.
Yeah, I'll submit with that one once
Next
we
one.
get through all of them. I'm not sure how else we could figure that out.
Yeah.
All right, the next one was 9, right? So obviously that one's DF, right?
Yeah, but how is that?
Yeah, I'm just confused because
wait, are we talking about number 15 now?
Number 9.
Oh, we missed number 9 too.
let me make sure I put the right one. That could. Okay, it is N. I put DF on accident.
I say that
Sorry.
does not make
Oh,
sense.
okay.
I was looking at that. I think that I'm pretty sure it's N. That was totally an accident.
All right, so let's try number 15. So you see, the p-value depends on the alternative hypothesis in general.
I think it's C.
That we don't have enough information. Yeah.
Yeah, because
I feel like I
I
always
tried
get
to,
my greater than and less than symbols mixed up, so didn't know if it was B or D.
so should we try C then? So not enough info.
Yeah, I think
Yeah.
so, because it'll depend on the confidence level and how many, and all that kind of stuff. So too many variables in play there, I would say. So number 17.
All right, we put 3.199 for 17, right?
Yeah.
Yeah.
Hmm. Not sure what else it would be.
Oh, we didn't times that by the t-score, did we?
Oh, you're right. You're right. Exactly right. Got that part of the equation. So 3.199 times.
Oh, so it's actually the mean though? That doesn't make sense. So it'd be 11.955, but that's the mean. We could try that though.
What's the equation we used for this again?
So it's t times the standard deviation of the differences divided by the square root of n.
Okay.
Is by itself. So we
What
need
was that?
the t is by itself in the equation, right?
Yeah.
So I just didn't want her thinking that you calculate the t times standard
Yeah, yeah.
There we go.
over all of that. So yeah,
So
I've got this the same as the mean. With that.
So you did 3.737 times 15.003 over the square root of 22.
Yep. Mm-hmm.
Hmm.
And I got 11.955.
I did too. Which is the same as our point estimate, and we got that right.
So in 17, you guys initially had 3.199, right?
Yep.
Right.
I'm just making sure I didn't put the right or the wrong thing in. Okay.
Okay, so there is a workaround. I think the answer is 6.652, because if you take the mean differences and then you calculate how far away that is from the high and the low, you get 6.652. So if you take the 18.607 minus 11.955, it's 6.652. And the same for 11.955 minus the low of 5.303. It's 6.652. And that's our margin of error, right?
Interesting.
The same. That's how.
Sorry, guys. I somebody came to our door. I had to go answer it. Are we still on question 17?
Yeah.
Yeah.
So I was saying,
Yeah.
I think if we just take the confidence interval, the highs and the low, and minus that from our mean of 11.955, you get 6.652, because that's the spread, right?
Yeah.
That the margin of error is the same as how far away it is from the mean.
Yeah.
I don't know if there's another way of doing that, but I'll submit with that and see how it goes.
Okay.
All right.
All right, so I'll go ahead and submit my responses and see how we did. All right, let's see. Number 4 is still wrong, so it's not 1.999. And we must have got number 9 right. Yeah, so that's N. And then 15 is correct, not enough information.
Sweet.
And 17 is correct, 6.652.
Good.
So we need to work on number 4.
Okay.
Which
Okay.
being that it's one of the first ones, it should be one of the easiest ones to figure out.
Yeah, you'd think so.
Okay. I just feel like they always talk about like finding the p-value, but I've never seen that in the videos.
Yeah.
Maybe I'm just missing that every time.
I feel like we went over it, but now that we can easily just put it in Excel, I've forgotten how to do it.
Yeah, I'm wondering if it's like just staring at us in the given
I'm going back to my notes.
Yeah.
I mean, do you think we're just supposed to put that number in for the test statistic?
I almost wonder if maybe we should just try putting in the 8 degrees of freedom and shading both the right and the left.
Mm-hmm.
Or is it just 0.0403?
I don't think that's just the answer, 0.043.
Yeah. They're saying use that probability to determine the p-value. So I wonder if we need to put it in that old applet.
I think they would have given us that if we were supposed to.
That's what I was thinking too.
Yeah, I think so.
Well, what we could do, we can try a couple things. I honestly think we might be able to shade both sides because the t-score is 2.444. Just to see if that works.
Yeah, let's try it.
Yeah.
And then I'll submit. Okay.
So, did you get 2.44?
Yeah, and I'm going to submit here really quick. Sorry, it's just taking a minute to load. Nope, that's wrong too.
Hmm.
Well, this stinks.
Yeah.
I'm looking back in some of the past chapters trying to figure out what we did before to get that p-value. What was the calculation?
Yeah, I'm reading through chapter 12 right now.
Yeah, it was always the z-score was the probability. Was that the same p-value? Yeah. Let's see. Well, if this is supposed to refer to all the information from question number 3 as well, it seems like we should be able to just plug all that into the sample t-test.
Mm-hmm.
Let me try that. Let's see what.
Saying the D with the line.
D with the line is supposed to be the differences mean.
Hmm.
So I went into the Excel sheet for paired sample t-test.
Mm-hmm.
No idea if this is correct, but up in the summary statistics table,
Mm-hmm.
I put in the differences mean for the mean is 2.2, the standard deviation as the 3.3, and then the n as 9, and that gives a p-value of 0.805.
Okay, I got that too.
No idea if that's right. Do you want to put that in, James, and see if that is right?
You keep like cutting in and out. So you just put all the numbers into that formula. Put
Yeah.
the
Into the summary statistics table in the Excel sheet. And it's computes the p-value to be 0.0805, so 0.081 is what we would put in for the answer for number 4. You want to try and see if that comes back as being right?
So you put
So you cut out right
0.08.
at that. Oh, sorry.
Although I didn't put in that probability information at all anywhere.
Oh yeah, me neither.
Oh, this is tough. Okay.
Where would probability even show up on any of these?
So isn't probability supposed to be just 0 or 1? It either is possible or it's not. I thought that's what probability was.
What if we put something in, like that number in where it says null hypothesis?
Oh, I've never done that. Yeah.
I haven't either. It's probably not right. It seems like, let me see.
Well, if
So
our
change.
statistic. Oh.
No.
We
I
always
mean, we've never tested any probability. What was that, Ginger?
Is T always the test statistic, or is it the sample mean, the D? The point estimate.
I thought it was always the test. I mean, I've never seen it.
Yeah, so in the testing steps, compute the test statistic, and it shows T as that test statistic. Maybe. But didn't we do that formula in the first place for the test statistic? Two.
Okay, I had 403 for the null hypothesis, and then greater than. So that gives me the p-value of 0.042 or 0.043.
Yeah, I think it might be that.
I mean, I can't think of anywhere else where we put that variable in.
Right. And the p-value, is that the same as the probability? And, I think we might be going back to what you're saying, Josh. I think that 0.0403, the given, might be the answer.
Probably is.
If it isn't, I think I'll live with getting one question wrong.
Well, have you submitted it already once, James?
I can go ahead and submit that if you want.
Well, did you? Is there anybody who hasn't submitted once already? Or we all have?
We all have, I think.
Oh, okay. So we've already gone around that.
Yeah, I think it's my turn.
You can take one for the team. Hopefully you don't. Hopefully it's right.
It's all good. I will submit right now. And sorry, I keep hearing you guys going in and out. I don't know if my Wi-Fi is just going crazy right now.
We hear you good right now. So just stay where you are.
Well, that's good. It was wrong.
0.0403 is wrong. Okay.
Yeah. So that wasn't it.
Huh.
No clue.
Well, maybe. Are you guys okay with me trying the 0.0426?
Yeah, but where'd you get that?
So that's if I put the 0.0403 in the null hypothesis, and then I change the type of test to greater than.
Okay.
I don't know. I mean,
It's worth a shot.
yeah, I'm probably going to
I'll
get
be
it wrong.
more than happy to test it out because I have no clue what this thing's trying to get us to do. Let me just finish refilling mine out.
No, I actually have another shot at an answer too. I was thinking maybe we could put that 0.0403 in the t-score, and then taking the area shaded to the right, which would be 0.4844. Also, I think we're going. I have somewhere to be in 10 minutes. Would somebody be able to? So I'll start with you guys on the second test. But would somebody be able to send me the answers, and I'll go through it by myself and check with you guys' answers?
Yeah, for sure.
Yeah, because I'm gonna run out of time here in about 10 minutes. So
This has never taken us so long.
I know, right?
yeah, I have 2 other classes I have to do tonight, and we have a group meeting in 10 minutes.
I totally understand.
Yeah.
Sorry to bail on you.
Fine.
No worries. Did we try the 2.44 already as an answer?
Yeah, we did.
Okay.
Now, where's the wasn't there a time where we would divide it by 2?
Maybe this is it, since it only has.
Mm-hmm. Divide or multiply by 2.
Yeah, because they just want the one-tailed. Maybe
Mhm.
this is it.
Okay.
So maybe it's
Let's see.
2.44 times, or was it 1.99?
Yeah, we had 1.99.
I'm gonna double check this really quick.
Which is 0.9995, which would round up to just 1. I'm going to put in number just 1 and submit. I'm just done with this one.
Yep, this question's driving me nuts.
Yeah, 1 is not right. So
Okay.
Now, if I divided 0.0403 by 2, I get 0.0202. I'm going to try that.
go for it.
See how that goes.
Nothing to lose at this point.
Yep.
Any guess is going to be a good one. I wonder if it's half of 2.44.
Yeah.
Yeah,
That's not correct.
yours wasn't correct. I'm gonna do half of 2.444 and see if
Okay.
and it'll load. Nope, that wasn't right either.
All right. Well,
I say we just move on to the next one.
yeah. Should we
Yeah.
say we're done?
Yep.
All right. I'll have to disconnect and call you guys back.
Sounds good.
All right.
Bye.